Alright, one more problem. It's like I cannot stop solving your homework for you. This is a lovely problem, also not a very difficult one, not difficult one at all, if you're not intimidated by the formulation. So I will just make it full screen and you can read the problem and figure out what it means. So stop the video now. Elimination is proportionate to the square of the reciprocal of the distance between the point and the light source. So that is a sentence that you can, first of all, understand what it means, and second, convince yourself that it is true, or like get a feel about it. In any case, proportional to the reciprocal of the square, or square of the reciprocal, it's really the same thing. So read this few times, as you should with all the story problems. And one is 10 times the intensity of the other. All right. So let me switch to Sage and start writing formulas. All right, so I literally wrote what was given to me, k, which is a coefficient of proportionality, times 1 over x squared. In other words, I will be k over x squared. And I need to bring up my super crappy picture, also my very first picture in Paint, at least since I'm an adult. All right, let's try that. So we have two light sources, a big one and a small one. The distance between them is 7. The distance to our point in between is x from the big light source, so 7 minus x from the small light source. And we want to minimize the illumination, find the coordinate x, counting from the big light source, so that the illumination is the smallest. Illumination from big light source will be k over x squared. Elimination from small source will be k over 7 minus x squared. K divided by 7 minus x squared. So this is the function that we need to minimize, and hence I can do that right away. So my total illumination will be the sum of illuminations k over 7 minus x squared. And this is the function I want to minimize with respect to x. So I'm going to consider di, derivative of I, diff I with respect to x. And I want to see it, show di. All right. Interesting. Wait, I did not rerun this. So here we go. I tried something before, so just to make sure it works. And now let's just equate it to 0 and solve. So solve di equals to 0. If it's equal to 0, you don't have to do the whole bracket equal to 0 thing, but we need to say that with respect to x. And let's try and see if it works. It's thinking and thinking for a while. Worst case scenario, we will have to cancel k. Here we go. We have 3 roots, 2 of which are imaginary. So that is an interesting thing to think about, what that would imply. And there is a real root at 7 over 2. And at this point, pause and think what I did wrong. Go back to the problem. We got the reason why I'm cautious, and you should always check the problem after you solved it, just to make sure. The reason why I'm cautious, I got a point in the middle. I remembered that one source is 10 times the other, intensity 10 times the other. So this was the more intense one, the one at distance 10. So this is 10 times k. And let me run this again and rerun that. Oh wow. In any case, we got some irrational, complex numbers, which we don't need to have. And we got a real number, which is what we want. This number is a little bit more complicated than I would expect it to be, but nevertheless, we got the answer. That